First, let's just use variables here, p and q, which we do not know what they are. But we know something about this box, right? What is p and what is q minus p? That has to be 6. So q minus p equals 6. What else do we know about this? This side AB is horizontal. Therefore, they have the same height. So if I plug in q into the red one, let's do that. That is 2 log p base A. That has the same height as the blue one when I plug in q. Aha, very good. Now I'm going to use the property of log to raise this to the second power here. Okay, now look at this. We have the same log value and I have the same base. What can I conclude? Oh, whatever that was inside must be the same. So we get p squared equals q. Well, then again, we knew that q minus p equals 6. All right, what do we do? Well, let's use substitution because this screaming to you is screaming out, I want to be substituted. Q is same as p squared, so I will use p squared here. So p squared minus p equals 6. All I did is I replaced this into here. Okay. This is quadratic, so I have to solve it by factoring. That's what I get. So it's p minus 3 and p plus 2 equals 0. Okay, so p is 3 and p is negative 2. Negative 2 doesn't work because we are dealing with logs here. You know, before I raised up the second power here, 2 was in front. You cannot take log of a negative number, so this is out. So p is 3. Let me erase this and put 3 there. P is 3. Okay, then what does that tell you about q? Q must be 9. For various reasons. Because if you plug in 3 here, q has to be 9. If you plug in 3 here, square this 9. But then again, you know the length has to be 6, so it has to be 9. So that's what it is. Very good. We found P and Q, which they never asked. They asked for A, not P and Q. Okay, well, but what we did is this. We just used what we knew. We know that this length is 6, so we just took advantage of that. Can we use something else that we know so that we can get some equation out of it and solve something? That is, this height is 6. That is, if I plug in 3 into green, I get that height. If I plug 3 into red, I get that height. If I subtract, I get 6. Shall we? This is the green. So 3 log 3 base A, right? Instead of x, I'm plugging in 3. If I subtract log the red one, I'm plugging 3 into the red one. This is the red one. So there was 2 in front, right? 2, 3 base A. The height difference has to be 6. Okay, using the same technique we used before, we will say this 3 goes to here. And this 2 goes to here. Why am I doing this? Because so that I can combine these logs into a single log. See, when you subtract 2 logs, the whatever is inside would divide. So what would it be? 3 to the third divided by 3 to the second. That is just 3. So I get 3 base A is equal to 6. How do you solve for A? You can't the way it is. Turn it into exponential form first. That means a to the 6th equals 3. Okay, now you can take 6th root on both sides. Basically, you have to bring this to the surface before you can deal with it. So A is 6th root of 3. That's the answer.